Now the loading process is complete, and the program, the source code transmitted on the serial port has come here in the page 5 of the Aleph memory. Alright, now we can see here the program in memory. Here we can see the addresses increasing while the source code is viewable on the screen. We are scrolling on this source, and the source code is exactly the same as we have on the other PC that I show the viewer pressing the VK. Oh, sorry. This is the bin version. Here is the ASM version. Here, exactly the same source code that we have on PC, on Intel Pentium 1. We have transmitted from here to Aleph, and we can see this on another PC connected with the RESI as a video terminal. Now the source is in memory. What shall we do with the source code in assembly on the Aleph machine? We can compile this source code with an ASM compiler that I made some years ago, and works perfectly on this machine. And a curiosity, just a little curiosity. This source code is not capable to run directly on the Aleph machine, because this source code is made for the CP/M, and we can compile this executable COM file for CP/M from the Aleph developer ambient system, and the COM file can be compiled as an executable form in the page memory that will be occupied by the CP/M operating system. That on the Aleph machine, the CP/M is only a subsystem, it's not the main operating system of this machine. Well, now I go to compile this source code. The first command is Samba. Is a symbolic analyzer. The symbolic analyzer is a preprocessor for assembly directive and labels. Each define that we can see in the code. We can use this other PC for show you the way. All these become an address on the source code, and after they can become a binary executable, just executing AZ80. Now we can see that executable will be on the page 1. Right. Second phase, the executable code is now on the page 1. We can dump for viewing this executable code. And so on. Now, in the memory page number 1, here we have an executable code for the CPM, not for Aleph. In the page number 5, we have the source code. The program dump that executes the memory dump, or the type that types the scrolling lines that you see on the monitor, is resident here in the page 0. Here we have the code. Here in the page 5 we have the data, and here in the page 1 we have the executable for CPM compiled by an ASM that is resident in the page 2. So in this way it is easy to understand that this machine is a machine that can address more than 64 kibytes of RAM. This machine has the same memory of the first PC IBM XT and can run the CPM as a subsystem. The system that was the main system for the Z80 now is just another program that runs in the large memory of the new Z80 way of programming done by the Aleph MMU. And now I try to show this by loading an image disk of CPM. By doing in this way, I can load the program from the memory page 1 on the virtual disk of the CPM by using a CPM subsystem command, the command save. Because save, if someone of you remember how does it works, saves a CPM page just 255 bytes of memory for each page. Save us this quantity of pages on the disk. It's clear that a page of CP/M is different from a page of Aleph. The page of Aleph is 64 kilobytes of RAM. Instead, a CP/M page is just 255 bytes.